Hello everyone, this is Mr. Eman. So today I would like to talk about the HKDSE sample paper Mathematics Compulsory Paper 1 Session B, question 18. Please read the following message, as this is the foundation of the whole series of this video. If you don't have enough time, please pause the video now. Otherwise, please stick with me for the question explanations. For any scalene triangle, if we need to find some angles or length, we usually use sine law or cosine law. But when do we use sine law and when do we use cosine law? Is this easy? When we talk about the relationships between two sides and two angles, then it is sine law. Otherwise, when we talk about three sides and an angle, it is cosine law. In our case, we need to find BC and BD in part A. So let's look what we have. BC is here, and the opposite angle of BC is 45 degrees. And we also have the length of 20 with his opposite angle 30 degrees. So we are talking about two pairs of angles and sides. So we choose sine law to find BC, just as the PowerPoint shown. Remember to put back the unit at the end of your calculation. So we also need to find BD as well. So BD is in a triangle, which is not a scalene triangle anymore. It is a right angle triangle. Whenever we look at the right angle triangle, our responses should be 2. It is either Pythagoras theorem, which is talking about three sides relationship, or trigonometric ratio, which is talking about the relationships between two sides and an angle. So look at triangle CBD. Because we have already got BC, so finding BD is not difficult anymore. We just use simple geometric ratio. Sine 30 degrees equals BD over BC. As we know, BC is 20 times 2. So we have the number we have. And so we have BD equals 10 times root 6. Let's go to the part B. In part B, the paper triangle is now folded into the shape as shown in your paper. And it is given that AB, the distance between A and B, is 18 cm. We need to find an angle between two planes. Let's look at the methods of finding angles between two planes. Oh, sorry. Okay. Now, in our revision, we first talk about an angle between a line or a segment and a plane, and then we go to an angle between two planes. Two planes. I keep saying one. Sorry. Two planes. Okay. First of all, we have to find a contact. And in this case, the contact is between the line AB or the segment AB and the plane WYZ is A. And then choosing any point on this line AB. In our case, I say B. And there also an image or a project point, which is vertically project point B. We call it B dash in here. We need to have a project point B on the plan WYZ to form a right angle triangle. And then the angle between a segment and a plan is angle BAB dash. Remember, A is the vertex of this angle. Now, what about two planes? Two planes. So again, we need to find a contact. In our case, the contacts between the two planes. I'm so sorry. I don't know why today I cannot say planes so naturally. Okay, angle between two planes. Angle between two planes. First of all, just like the case before, we need to find the contact. In our case, it's segment AB. And then we have to choose a point of plane ABC, let's say P. And this P, we also need to find the vertical vertical projects of point P. Find it on the plan WYZ. Okay. However, there is one condition we have to pay attention. If we got a point on one plan, which is P, and this P should have a line formed with the contact segment, then PM must perpendicular to AB, and also P dash M, this line is required to be perpendicular to the contact segment AB. That means if we want to find an angle between two planes, we have to find two lines, and these two lines must perpendicular to the contact segment. Okay, so in our case, the angles between these two planes is angle P and P dash. The vertex of these angles is N. So let's see what we can do here. As I said, we have to find two lines which perpendicular to the contact segment. In our case, there is a green plane and the red plane. And the green plane have a line which is BD, and this line is perpendicular to CD, and AD from the red plane is perpendicular to the contact segment CD. In this case, unfortunately, we cannot find right angle, which makes our calculation easier. Instead, we use a scale line triangle ADB to help us to find the angle between two planes. Okay. So, because we have a chance to, we have already got 9 BD, and we also have the chance to find AD, and the line AB is given, which is 18 cm. So we have three sides and an angle. Then we use cosine law to find the angle between two planes. As I say, AD is very easily to find because we have already long AC, which is 20. So with the simple geometric ratio, we can find AD, which is 10 times root 2. So as I said, we will use cosine law to find the angle. So the angles between two planes is 46.6 degrees. Let's go to the question B part 2. 18B part 2. It is talking about now the two planes can move freely. However, the angles between the two planes must be between 40 degree to 140 degree. And the question is interested to know what kind of changes will happen to the volume of ABCD. The volume of ABCD is calculated by 1/3 times the base area times the height, which is the usual formula for pyramid volume calculation. Okay, then we sub back all the lengths here. Because the lengths are fixed, we concluded that the volume ABCD is proportional to sine theta. So we need to investigate the behavior of sine theta. I use a graph to illustrate. As you can see, sine theta graph is just like two semicircles. From 0 degree to 180 degree, we have semicircle, and the peak will make sine theta equals to 1. And then from 180 degree to 360 degree, we will have the minimum minus 1. And we can also see that from 0 degree to 90 degree is going up. The value of sine theta is going up. And then it is going down from 90 degree to 220 degree, and finally going back to 0 from 270 degree to 360 degree. However, in our case, we are just interested between 40 degree and 140 degree. So we see that the volume the ABCD volume is affected by sine theta, and sine theta will go up and down between 40 degree and 140 degree, and we need to divide it into two parts at 90 degree of sine theta. So I make this conclusion for the solution. When theta goes from 40 degrees to 90 degrees, sine theta increase, and so the volume increase. However, when theta goes from 90 degree to 140 degree, sine theta decreases, and so does volume, and so does the volume. Okay, thank you very much for your attention. And if you have any problem, please email me. Thank you and goodbye.